Hey everybody, this is Mr. Brooks, and we're going to do these notes on complex numbers right now. So you guys have this complex notes and or complex numbers notes. So just the definitions: a number whose square is less than 0. So a negative number inside of a square root is called an imaginary number. On the deep dive video, they like to use the word lateral number, and I like that name a little bit better too. But it's designated with this I right here. So the square root of -1 is I. And the way you do this is essentially if there's a negative number inside the root, then you have an I when you simplify it. So the square root of 16 is 4, and the square root of -1 is I. So right here you have 4I. The square root of -16 is 4I. And then right here, square root of -8 is like saying square root of -1, square root of 4 times square root of 2. And the square root of 4 is 2. Square root of -1 is I, and then the root 2 stays. So back at the beginning of in foundations, we did this where we simplified square roots, and now it's just one more step. You can add, subtract, and multiply and divide these. If you want to add them, 5i plus 3i, you add the 5 and the 3, that would make 8i. If you had like -2i minus 6i, that would be -8i. So you can subtract it just like you can anything else. I to the 0 is 1. Anything to the 0 power is 1. And then I to the first is I. And then I squared is -1. And I to the third is -I. And what's going on right here is you can see this. You start at I to the 0 here, and you're moving 90 degrees right here. So I to the 0 is, just to make sure you're aware, this is a complex plane. So this is 1 here, and this is I right here. But I to the 0 is 1, and then you square it, and you go up here to I, and then you square it again. I times I, no, that's not, that's 1 times I, and then I times I, so we're squaring it, and you get to -1, and then you multiply by I again, and you get to -I, and then you multiply it again, and I to the fourth is equal to that same 1. The I to the fifth, you come back up here, and it's back to I, and then -1, and then -I. And you should see a pattern where it just repeats in this circle again and again and again and again. And so you guys can fill that in right here. But it basically repeats that 1i, -1, -I, 1i, -1, -I. And a way to think about it is you divide the exponent by 4 and you see what the remainder is. So for I to the 17th divided by 4 is 16 with the remainder of 1. So it's just like having a remainder of 1 would be right here. It'd be I. And then 26 divided by 4. For this one, that would be 24. You can count 4, 8, 12, 16, all the way to 24 with the remainder of 2 to get to 26. And so it would be the same thing as I squared, which is -1. Okay, so complex numbers. So we're going to say complex numbers and imaginary numbers, and for us, essentially, they're the same things. A complex number has 2 parts, as a real and imaginary number. If the real part is 0, you say it's imaginary. But, you know, I mean, if you're saying complex, you're saying imaginary. If you're saying imaginary, you're saying complex. A is the real part, and then BI is the imaginary. So for example, given 2 plus 5i, the real part would be 2, like 2 is A, and then the imaginary part is 5i. Combine like terms, you guys add and subtract these with like combining like terms. So if you just add them, you have negative 3i and positive 5i, that's positive 2i. And then 8 and then 2 is 10. Notice I'm following this A plus BI. The real comes first and the imaginary second. Same thing right here, 7 plus 11 is 18i, but I have to put the real part first. So 8 plus negative 12 is negative 4, and then the I is positive in this case. Right here, you want to be sure you subtract both of these. So, you know, just because you see a plus sign right here, you're still subtracting. So 9 minus 12 is negative 3. Negative 6 minus 2 is negative 8i. Multiplying. Okay, so we're going to use our multiplication knowledge of multiplying radicals, outside times outside, inside times inside. So the outside numbers are 5 times 4 is 20. And then the inside numbers are, oh no, we need to, I'm sorry. We need to handle this first. So this would be 5i root 2 times 4. Oh, no, it doesn't matter. You could have done it the other way. There's a special trick right here. I'll show you. Sorry, I'm going to do it this way. I'm going to pull the I out first. But you can do it the other way. So this is 4i root 8. Okay, so there's a special thing. Whereas I times I is I squared, and I squared is equal to negative 1. So this would have worked out anyway. But in this case, we're going to multiply the outside times the outside, inside times the inside. And when we have I times I, we're going to change it to negative 1. Okay, so if you have I times I, you're not going to have an I in your number, in your answer. So 5i times 4i is 20i squared, but that's going to change. And root 2 times root 8 is root 16. Okay, so then it stays at 20, and then the I squared turns into negative 1. Remember, I squared is negative 1. And then the root 16 is root 4. So I think, yeah, it would have worked out anyway. So this is negative 20 times 4 is negative 80. Okay? And then right here, I'm going to change colors, but you want a FOIL. So first, outside, inside, last. So negative 6 times 2 is negative 12. Negative 6 times negative 3i is plus 18i. And 2i times 2 is plus 4i. And 2i times negative 3 is negative 6i squared. So now the middle ones are going to combine. So I have negative 12 plus 18 plus 4 is 22i. And in this case, this I squared is going to turn into negative 1. It's going to turn into negative 1. So it'll be negative 6 times negative 1 is positive 6. So I'm going to add 6. So the 6 and negative 12 turn into negative 6 plus 22i. Okay? So let's see what else next. Complex conjugates. The complex conjugate of a plus bi is a minus bi. So the conjugate is the same numbers. You're going to flip the sign in the middle. So let's see, multiply complex conjugates. When you multiply these by FOIL, you're going to see the same pattern. It's going to be a squared plus 2bi b's. It's let's think. It's a times bi is abi. It's 2ab. It's going to follow this. I'm pretty sure it's going to be follow 2a times b. And then I. And then this is going to be bi squared, but I squared is going to be -1. So it's going to follow this pattern. But it says multiply the numerator and denominator by the complex conjugate of the denominator. So we're going to multiply both sides, both top and bottom, by 7 minus 4i. So it's the denominator. It's the complex conjugate of the denominator. And then this is 7 minus 4i. And the reason you're allowed to do this, in case you're wondering, like, how is this possible? It's because anything divided by itself is 1. So we're multiplying by 1. And that means that we're keeping it the same. So on the bottom is going to be 7 times 7 is 49 plus minus, no, this cancels out. This cancels out. It cancels out. That's what it does. Boom. Because when you multiply these, you'll get plus and minus the same thing. So then you have plus 4 times -4, that's 16. So it's going to be minus 16, but it's going to be plus, because it's going to be minus 16i squared. I squared is -1, so -1 times -16 is positive 16. And that on the bottom is going to be equal to 65. So 65 is on the bottom. And then on the top, you're going to have 7 times 5 is, this is FOIL, 5 times 7 is 35. And then 5 times -4 is -20i. And 2 times 7 is 14i. And 2 times -4 is -8i squared. So that's going to turn into positive 8. So 35 plus 8 is going to be 43. So it's going to be 43. And -20i plus 14i is going to be -6i. And that's fine. That's fine. That's fine. That's fine. That's fine. You can have an I in the numerator, but you may not have an I in the denominator. That's why we're doing this. Multiply the denominator by the complex conjugate so that you don't have an I in the denominator. Right here, it would be 3 plus 2i. No, it would be 3 minus 2i, the conjugate, and 3 minus 2i. So this would be 9 plus 4 is equal to 13. And then on top, it would be, let's see, 9. Oh, look at this. This is what I'm thinking of right here. It'd be 2ab. So it'd be 6, 6i minus 6i. It'd be -6i minus 6i is -12i. And then negative 2i times negative 2i is positive 4i squared, but it'd be negative 4 since I squared is negative 1. So 9 minus 4 is 5 and minus 12i. So that's a crazy one. Okay. Finding the complex solutions right here. You can do this a number of ways. You can factor. You can use the quadratic formula. You can GCF, or you can use the square root. I'm going to use the square root. So I'm going to subtract 100. And that's going to give me 4x squared is equal to negative 100. And divide both sides by 4. And that'll give me x squared is equal to negative 25. And then we're going to take the square root of both sides to cancel out the square. And x is going to equal plus and minus 5i. And then same thing right here, minus 48 both sides, divide by 3. And x squared equals negative 16. And so x is equal to plus and minus 4i. And you take the square root, of both sides to cancel off. Okay, so just a few more to practice. This would be 12i because it's negative. This would be 2 plus 5i, and that is fine. This would be, let's see, 20, it's negative 1 and 4 and 5. And so this would be 2i root 5. And, okay, so right here is 35. 35 divided by 4 is, let's see, 36 is 9. So it'd be 32 with a remainder of 3. And so I to the third is 1. No. It goes 1, it goes I squared, negative 1, I squared is negative 1, and negative 1. It goes negative 1. So the remainder of 3 is negative 1. I to the 16 is a remainder of 0, so that's 1. And I to the 62 divided by 4, oh god, 64 goes in, so it's a remainder of 2. So it's I squared, so that's negative 1. I to the third is not negative 1. It's got to be, let me think. 1i, negative 1, negative I. It's negative I. So this is negative I. There we go. Right here, this is a tough one. Let's see. I to the third is negative I. So this is negative 4i. And I to the ninth is a remainder of 1. So it's I. So this is plus 7i. So negative 4i plus 7i is positive 3i. This one is going to be the power rule. So this is 3i to the 5th twice. So there's actually 10 i's, so it's 5 times 2. So this is the same thing as 3i to the 10. That's a 3. And I to the 10th is has a remainder of 2, so it'd be negative 1. So it'd be 3. Oh no, this would be 9. This would be 9 I to the 10th, because it'd be 3 squared also. So it'd be 9, and then a remainder of 2 is negative 1. So it'd be equal to negative 9. So number 10 is equal to negative 9. Just a reminder right here, let's see, 8 minus 2 is 6, and 3i minus 4i is negative 1i. This one is, you gotta multiply it by the same thing. Don't just distribute the exponent. So and then FOIL, 3, 4. So 4 times 4 is 16. And then minus 12i is negative 24i. And then negative 3i times negative 3i is positive 9i squared, but that 9i squared turns into, I squared turns into negative 1, so it's minus 9. So this would be 16 minus 9 is 7 minus 24i. And is there anything else here? Let's see, this would be like dividing 3i. And so you want to cancel out the I on the bottom. And so you want to multiply by I. You can multiply by a number of things, but I times I is negative 1. So this turns into negative 3. And then this, you essentially distribute the I. So 1 times I is I. And then this is equal. And then negative 2i times I is negative 2i squared, negative 2i squared, because I squared equals negative 1. So I'm going to write this, negative 2i squared, which is equal to negative 2 times negative 1, because I squared is equal to negative 1, is equal to plus 2, so it's plus 2. And we should write that as a plus bi all over negative 3, and that's it. That's it. Okay. So there's some helping problems. Here's all the rules right here. It's called, this word closure just means that it is a number and you can do anything you can with regular numbers. Also, it's commutative. 2i plus 3i is the same thing as 3i plus 2i, so they commute. And all the other properties, identity property and reflexive property, all that counts towards it also. So